Mafachi, could you please, okay, you actually gave me the column names. There we go. I didn't see that. Sorry, that's actually my fault. Okay, so we'll do that, and then everything else looks fine. Again, your date and time, it's not ideal to store it that way, but again, in pandas, we can fix that quite easily. But let's use this data as a nice example to work with. We've kind of learned all the skills already to work with it. So yeah, let's work with that one. So because I don't want to run in all the other files before, especially this one, because it's quite large, I'm just going to comment it out. And how do you comment something out? I comment this line, for example. Click on any line and you should see comment or uncomment, right? So pandas will just ignore that line completely. A shortcut key is just Control-1. So can do Control-1 for all of these, just to make our life a bit easier. So let's get that data from accelerometer data. Pandas, so not pandas, but pd.read.csv. And then what is the path? Can somebody give me the relative path, please? I put it in chat files. So what should be the relative path? What should be the relative path? All right. Yeah, thanks, Petrus. So I'm going to chat file. Okay, well, I'm just going to copy it just to make our lives easier. I'll just copy the relative path and put the two quotes there. All right, so chat files. And then if we run this, we should see the data without any column names, which isn't nice to work with. It just takes the first row as a column name, so which isn't useful. So let us take, let's change that. We know what are the parameters we should use. So actually somebody said you don't need header equals none, which is unusual because I might have issues when I didn't do that, but let's try it, see what happens. I'm just going to say, where is the name? So column names. Well, I don't need that whole thing. I'm just going to do this. I'm going to say names equals that. So that should be enough. Let's run it. Go to data frame. And there you go. Okay. It does work without header equals none. For some reason, I was thought you needed header equals none. Okay, well, it does work. I think there might be a reason why you use header equals none, but I can't remember now why I do that. But yeah, so everything looks fine there. Again, this date time is not structured very well, especially if we want to do time series analysis. You definitely want to split that up. And you also have a NAND here, which we can easily remove in pandas. So data looks fine except for the date time. Shouldn't really be stored like that. Okay, thanks for that, Tato. It was a nice file you gave me. And yeah, so I think that's all. 2 examples. Oh, we also have a JSON file as well. Let's see what this looks like. Normally you should know what this is. What is that? What is a genome mining tool that looks for biosynthetic gene clusters in bacterial genome? That's a mouthful. I have no idea what it is. Yeah, well, let's see what it looks like. Let's get the file and put it in our chat files. Open it up. I did download it already. Can you explain what it is normally? You're the resident expert. data over here. So should I wait until Friday for you to explain what that is? Next Friday, okay. Because normally it's doing presentation by informatics. So PD, so it's not read CSV, but read JSON. And let's see, there it is. See what it looks like first. It opens up. Yeah, it's probably eating away on my memory. I think it opened up a notepad somewhere. Or it's opening up some other program. But in any case, let's try and read it. Or not crashed my spider. Alfred is asking where are the names coming from? Yeah, so Tato gave us the names for that file. So that's why I put it there. So it was missing. So Tato gave me the files, and Rahul says, may you please send the bacterial genome file? I don't know what you mean by that. I don't know what a genome file is. So it seems like this file is too big and it's crashing my spider. Thank you. Thank you for that. So that's a good practice to see how, to resolve this issue. So let me close spider. Python is not responding. Okay, let's open it up again. Oh, I think I tried to open up another program as well. So let's look at this file. It shouldn't be that big. Oh, I have another XLT file. Store. There we go. There we go. So let that run up. And I see another file here, an XLT file. I don't know what XLT file is, but does Pandas work with XLT files? Can anybody tell me? I don't know. Maybe it does. I can already see from the image that there's header information or metadata, and that's going to be a problem. So you probably have to use remove the first few lines to be able to resolve that. Yeah, so that's Lumco, assuming you sent that data, right? Okay, XLT. So Andrew, I'm assuming then you can open it, right? Yeah, so somebody asked, how do you increase the zoom for console? You just say Control Shift plus. That should work. Well, let's see if it has it. So this is df equals pd.read. See what options we have there. It's not happy with me. There we go. No, I don't see XLT, so I'm not sure about that. So if somebody can Google it, find out for me if pandas works with XLT. Otherwise, we're gonna move on from here. Okay, so the next section in the notes, focuses on transforms. So just need to quickly resolve this problem I have here with this JSON file that I sent. Is transforms, and part of data engineering, it's about a large part of data engineering is doing the ETL part, which is extraction, transformations, and loading your files in some way or form. So we've done most of the extraction part, how we extract data from files or URLs or any other type of format. So we've done that. And usually there's an overlap as well between the two that we'll cover. And even with EDA, during the process of extracting and transformation of the data, we're doing analysis of the data at the same time. So these are common tasks and roles that you do, almost second nature, but it's useful to classify them as well. If you Google what ETL is or EDA, you'll see it's quite common terms. Okay, let's look at transformations. So where were we? Student view, and then so transformation. So as we saw in the previous lesson, sometimes the data is incorrect. Right? There are many ways to clean or transform files. And sometimes this is done in the extract process as well. So there's overlap between the two. And again, we've looked at this before. We've looked at read CSV and various parameters we can use and we read in the data in a correct format or in a correct way. If there's, if there's not enough, if the space is different, if there's no column headers, sometimes if you have a large file itself, when we start looking at big data, you can use something called chunking as well, which is something I can cover if you want to, but it wasn't a plan for this week. But if you want to look, if you want me to comment on big data as well, I can. Pandas isn't really suited for big data. There are other Python libraries that are more suited, but it can handle files to some degree, large files to some degree. So some of these things we've covered already with the index column, to kind of have removed that. So maybe let's look at this example again with the country data. Sometimes you want to just remove a column or the index column. You don't really need it. So let's have a look at that one. That should be in files over here. Data 2, yeah. So I added this extra column, just the index column in the CSV, which will become redundant because pandas, when it reads in data like this, it'll create its own index for you. So let's read that in and let's see what it looks like first. Sometimes you might see this quite often if your data is in that format. So it's a df equals pd.read CSV. Let me just comment out the previous one as well. Read CSV, and we're going to be using some data. Oh, let me just copy the relative path. Add the double quotes. and run it. Okay, so if we go to Variable Explorer, we'll see that in our data frame, you'll see there's an extra column here, which is kind of redundant because again, Pandas creates an index column for you already. So how do you remove that? You just say one of the parameters in read CSV is this index column, and you just set that to 0. So just ignoring it. And if you run it again, then that index column disappears. So sometimes your data might have an index column, or maybe the first column is a different format, might not be 0 to n. So sometimes it's useful feature. We've done skip rows already, so I won't cover that. I saw the other example we had with the XLT file. You can see we need to use skip rows again just to skip all those other metadata that describes the CSV file. And column headings, I'm not going to cover that. We've done that today and yesterday where you don't have column names, and you can easily just add that. There's other examples I have here, which is, just share this so we're all on the same page. So we've done skip rows already. We've done column headings already. Unique delimiter with the text file where we had the semicolon. We've done this. So I've done all these examples already. This is just a recap ready for you. So the one we're going to look at now into a bit more depth is the Excel file. And we're just going to show you a few examples of how to transform the data or change it to make it more useful maybe for you. And maybe some unique features of Pandas that you haven't used before. All right, so let's go back to the Excel file. So let me just comment this all out. Where is that Excel file we had here? Here we go. Just copy it and put it down here. Let's call it DF rather, just to be more accurate, because this is storing it as a data frame. Okay, and I'm going to run it. Go to data frame. You'll see this is the data. This is the various columns we're going to work with. Okay, so the one thing I mentioned, so some of the column names are, maybe you actually can't see it too well here. If you can probably see it in the Excel file itself. So we can open up the Excel file. This one over here. So this is just really sticking to standards. Not all the names are consistent. With some of them are uppercase, some are lowercase. So it's just this could be nitpicking as well, to kind of keep everything uppercase or lowercase. And again, mixing. If you just look at this column as well. Well, there's actually two problems here. I think I do mention it. Again, some columns are snake case. I mean, it has an underscore, others are all caps. Age distance column or age distribution. It has numbers and text, which isn't ideal. And some of the names for years, for example, aren't consistent. So you have YEA instead of YRS, which isn't consistent with the other naming convention. This is a categorical distribution, which is fine. So you can leave it as it is, but sometimes it's easier or maybe better to change it to numerical. Marital status as well. So again, they're mixing strings or text with numbers, which isn't ideal, especially in this case. This should be like a 0 or something else. And then you would have obviously maybe another file that explains, what these numbers have, right? So like a README file or metadata file that explains, these different numbers and what they mean. But this is just more for an exercise. If you wanted to, for example, change how this column is represented, right? If you just wanted to maybe store it in a different way, right? So the example I gave here was, let's just extract the lower range and use that as as your category, right? So how are you going to do that? Okay, so let's go back to Excel. So let me just add this. So what I mean by that is I want to create this. I'm going to do this in pandas, but I'll show you in Python as well. Sorry, in Excel. I'm going to create I want to create a new column called lower age. And what I want to do is, instead of saying 30 -34 years, I'm just going to extract the lower number, right? So be 30, and here be 35 and 30 as it goes along, right? So now at least I'm maintaining the numerical value, and then here I can say, this is in years. I mean, here you can add whatever metadata you want to describe it. So this can be years, and then can be range of 4, right? Range of 4, however you want to store it. I mean, it really doesn't make a difference, right? So then, I mean, the column name is explaining what it refers to, and then you're still maintaining the numerical value as well, which might be useful. So again, how do we do this in Python? So let's have a look. All right. So again, so we can go here. So we've read in the data. So we do have the data there as well, so that should work. Yep, so that's all there. Okay, so and again, what is quite useful, just let's have a look at some of the attributes of the columns, just to make sure we read everything incorrectly. df info. All right, so what do we see is that okay, age is an integer, which is what we expect, and it floats. Age distribution is obviously an object because you're mixing text with symbols and numbers. Various other ones, which seems to be fine. What is marital status? What is that symbol? So this is quite interesting, and this is how Pandas interprets it, because you can see these are all numbers, right? But if Pandas notices that there's text in it, it will define the entire column as text, which is not consistent and might give you issues, right? So this other should rather be like a number, like 0 or something else. You can define it outside. But again, if you have text in your column, the whole column will be defined as text. And you might be reading it or expecting to do some stats on it, but you can't because it has the text in it. And I think everything else seems to be fine. Yeah, so everything else is numerical, so we can still work with it. Okay, so how do we maybe fix this column, or let's create a new column. So the example is just like I did in Excel. How do you create a new column? Well, we'll just define it like this. So I just called it lower age. Let's do double quotes, lower age. So we did do this before yesterday. If you want to create any new column, you can. And what we're going to do is we're creating a new column based on what? Based on the other column, which is called age distribution, right? So age dist. Doesn't look right. Something like that. Okay. So what happens if we do that, right? If we just do that, what happens? We're pretty much just copying one column, the data in one column into another column, right? So if we run it, see what happens. you'll see that, okay, I get a new column at the end, which looks identical to age distribution. But we want to kind of filter this column. We want to edit it. We only want to extract the lowest number, 30, 35, and the rest, right? So we don't want the text and the numbers after that. So what we do, so we can use a built-in method for this specific column. Because it's defined as strings, and we know it's a string because when we printed out df info, we saw it's an object, so it's a string, so we can use a string in this case. And we're going to use another chain command called extract. So we're extracting something from each row. And what is it going to be? We're looking for a decimal, the first decimal number. Okay, so this is using something called regular expressions. We're not going to cover regular expressions in this course, but I'm just showing you a use case of how we can extract specific numbers in a specific format. But if you want to know more about it, you can ask me in the chat, right? So this will be the first number to extract. And I think that looks correct. So this will be what this stands for. Will be the first number and that you see before the hyphen. So if you run that, should work. There we go. So you'll see now that it extracted the first number and it's putting that into the new column called lower age, right? So this is just one simple example. It's more like a use case to show you how you can manipulate the data however you want. This, again, for people that are new to programming, this might be quite confusing. But again, this is just to show you what you can do. Learning these steps might take time, but this is more of a showcase example. Again, doing this also might not be too useful because it is more of a categorical data. But again, it's just a use case just to show you what you can do in pandas or Python, which is pretty much anything you can think of or code. You can do quite easily in Python or pandas. So I gave an explanation of, in terms of pseudocode, what it does in terms of it's searching for a number followed by a hyphen. Sorry, by a hyphen. If you find a number, extract it and put it in the lower age column. That's pretty much what this line is doing. So just one line, you can extract all that information and put it in your data. So yeah, so that is useful to know. But now there's one more step that we need to look at, right? So if we do df info again, you'll see that lower age is still an object. Why is it still an object? Why is this new column that we added? Why is it still an object if we want to extract the number? Why is it still an object? I want to ask you, Christopher, it's fine. Yeah, thank you, Tatu. We extracted it as a string. So that's why it's still storing it. It's still storing it as a string. That's why all those values in that column is still a string. So we need to convert it to what? We want to convert it to an integer. Okay, so how do we do that? Let me just copy this line as is, so I don't have to type it out again. So I'm going to say what I want to do is I don't want to create a new column. I want to almost convert what I have here in this column to an integer, right? So how do I do that? I use a built-in command called as type int, and I'm assigning it the output to this column, which I already have, and if I do another df info, run it, and you see now that that integer, that column is an integer type. So you can do, numerical statistics on it if you want. So again, we haven't covered this too much yet, but what are all these dot string and dot extract and dot as type? So these are accesses or functions or methods or operations that you can apply to columns, right? So these are built-in features of pandas that make your life easy, so you don't have to do it yourself. So within this will probably be like a few lines of code if you have to do it just using normal Python code. So within one line, you can do the same thing of like 5 to 6 lines of code. So again, how these work, it'll take time to explain. So I'm just giving an example and like a showcase of what you can do with pandas, because again, we can't cover that much just in a few days. So yeah, so what we're doing is just applying, we're applying the string operation to this column. And there are various other string operations if you look at it as well. So let me take it away. Let me just do it again. So let me just copy this over here. If you say put the dot character there and say string and dot again, there should pop up a whole bunch of other options. Not sure why it's not popping up, but it should. In any case, you can always look at the pandas documentation if you want to look at all the other options and operations you can do on any column data. Okay, so all right, before we carry on, I'm going to open up another quiz just to make sure everybody is still awake. Before we go looking at dates. So let me just open it up and publish it. Just give me a moment. So again, you can do that shortly. Let me just. Okay, so you should see Python quiz 3 now on data storage. So please do that now. Just 6 questions. You have about, I think it's also 10 minutes to do it. Yeah, so please do that quiz now. Yeah, so you have another quiz to do now. So please do that Python quiz 3 on data storage. Oh, it's still locked. Oh, sorry about that. Let me just modify that quickly. Give me a moment. I think it's because of this. That's why. Okay, should be unlocked now. So please try again. It's only 6 questions. Yeah, so you should be able to access it. I think we can continue. There's about almost 200 that have completed the quiz, average of 88%. So let's have a look. Obviously, we're going through the answers, but I know when you're submitted. So if you're obviously submitting it afterwards, then I know you're just copying the answers. Okay. So let's do data storage. Okay, let's take the quiz. Yeah, how do you add an element X to a list in Python? What do you use? UCT, here we go. When is it? Answer number. Okay, I already got the answer in the chat. So a pen, right? We're gonna use a pen. How do you get the number of elements in a list in Python? And shout out UCT, it's really fine. Nobody will hear you. Yeah, length, yeah, there we go. Output, question 3. What's output? Question 3, what's output? What is the output for question 3? And shout it out, I don't mind. Okay. Okay, all right. 2, 3. Okay, this is what we get. How do you access the value of a key in a dictionary X in Python? What is the answer for question 4? X key. The first one, right? Okay, what is the output of the following code? So it's the first one, I'm assuming. And the following question 6, what's the output for this one? First one, B2. Okay, let's see how I did. Well done, I got everything right. Cool, all right, let's carry on. What are we doing next? We're doing dates. Yeah, so who has started with the project? Just give a thumbs up. Remember to reply, have an over it and a reply. Just curious who has started the project yet. Both or either one. It's up to you. So anybody has started the project, you can give a thumbs up. It's very quiet. There's nobody. Ah, there's one. Fantastic. Okay. 2, 3. Okay, there we go. People have started. Thank you. Okay, so where are we now? We are, I think the last section is we're looking at working with dates. So dates can be an issue when you're importing it because, well, if you look at Excel, firstly, Excel spreadsheet or LibreOffice or the free ones, problem with dates is that format can change between different laptops. You give an Excel spreadsheet to somebody else, the date might look different. So the formatting for dates can be a problem if you rely on Excel itself, right? So the best way is just to store it as a flat format where it's completely obvious, what date you're actually referring to. So it's quite important, working with dates, you store it correctly. Yeah, so here's a little snapshot of the different ways, for example, Excel can store dates. Does anybody know what the second last one is over here? Actually, we can. see the one I'm circling. Do you know what this refers to? 44700. Not hours. It's not hours. Yeah, days from when? I think it's I think it's 1899, I think. So something like that. Somebody can Google it and find it, but this refers to the amount of, I think from 1899 or something like that. So that's why in Excel you can obviously add days. You can get the current day and say add days, and add them up. But yeah, just some useful information. All right, so working with dates. So most cases, when you read in a CSV file with dates, you're going to read it as a string, right? So this is most cases what's going to happen. Okay. Because if you look at all these examples, it has some kind of character in it or letter in it. So even this case, which is 190522, it has a dash in it, right? If Pandas sees a dash, it'll interpret as a string. So each of these cases, except for the second last one, it'll interpret, second last one will be obviously integer, but all the rest will be as a string. Okay. Yeah, thanks, Louise. Yeah. So 44700. Yeah. So it's a long time ago. But yes. So let's look at an example with the time series data that is on our spreadsheet. So can somebody in the chat give me the relative path for the time series data so I can read it in? Oh, wait, there was actually a few examples. Oh, wait, a few questions in the chat. Let me first cover that before we get into dates. There was a few questions from Raul above about the regular expression. Okay, so what does this mean? Again, I cannot do a lesson on regular expressions in time where we're doing Python. But suffice to say is this is a way to extract certain characters or numbers from a string, right? So you can Google what regular expressions are. So let me just type it here. Regular expressions. It is very useful to know about this. You have full control over the text, how you want to filter it or modify it. So this is a key, skill to learn if you're working with especially income data that has string in it and you want to format it or filter it in some way or form. It's very important to learn regular expressions, but we don't have time to teach it this week. And the syntax can be a bit confusing. So I'm only giving you one example this entire week of it. So primarily, what does it mean? So this part over here just means we want to capture a group that matches one or more digits. Okay, so the D, the backslash D refers to any digit that's 0 to 9. And the plus just means it must be a positive digit, or can be one or more digits. Sorry. So the dash just refers to what it should look for. It should find a number and it should have a hyphen after that, right? So we just using this statement over here to search for certain number that's positive. It can have multiple numbers and might have a hyphen afterwards, all right? So that's pretty much all that this means, okay? So somebody asked a question, how do we extract maybe the upper number, right? So if we want to extract the upper number, we can do that as well. So let me just copy this over here. So this one should be like upper age. This will be all stay the same. And instead of, we don't want the first number, we don't want the number before the hyphen, we want the number after the hyphen. Let's copy and paste it there. And if we run it, should get another column. in DF that has the upper edge. So there's the lower edge and the upper edge. Okay. So again, it's a showcase. I'm showing you what you can do. Anything that you can think of you can most likely do in Python. So any filtering or sorting or anything along those lines, Python is a very powerful tool in that sense, and can automate things like this a lot easier than what you can do in Excel. Yeah, so regular expressions isn't unique to Python. You can use it in other languages as well. It's a very diverse skill to learn. So, but again, we can't cover it this week. It's not enough time. So hopefully that explains that question. Yeah, I think there was the only question about what this does and how to extract the upper edge. Okay, so now we're going to dates. Okay, so as I said, dates, most likely when you read it in, it'll be as it will be a string, right? Because the examples I gave you, the dashes or the words in it, all the dots in it pandas will interpret that as a string. So let's look at an example. Could I have the relative path for the time series data, please? So please put it in the chat. Okay, Nancy did put it in there already. If you can make my life even easier, please put the double quotes. So I don't have to keep on adding double quotes. So PD read PD dot read CSV double quotes. Okay. So let's read this in and see what we get. This is time series data. Can't remember what it was again. Let's have a look. Okay, well, first thing, there's a very annoying index column on the side, and it has a date column and a temperature, right? So not too interesting, but something we can work with. Okay, let's first get rid of that index column. So index column equals 0. So we can just kind of remove it. We can do it afterwards as well, but we can just do it when you read in the data, So we don't have to do it afterwards. So we save and run the file again, then we should, yeah. So there, that column was deleted or just removed, or just not read in actually, not deleted. So we just have panda's own index column that we work with, and the date and temperature columns. This is what you want to work with. Okay, so okay, and now let's look at the format. Let's go print and see what the date was read in as, right? So info. It is an object, right? Why is that? It sees when it sees a dash, any character, any letter, any symbol like that. If pandas sees it, it'll interpret it as text and therefore a string. So another source of confusion is obviously the if you look at this format while we're on speaking about dates. Now, what is today's date is today is the 30th of 2024, right? So this is generally what we use in, I guess, the British standard and South Africa as well. In America, what is the standard there? So they first put the month, and then put wait, it's first the month, and then the day, and then 2024. So this is another. I've seen it in some of the formats as well on Excel, right? So this can obviously not work. You can't. I mean, somebody from South Africa, for example, looking at this, they can't have 30th month. But let's say, for example, you have this, right? You have the 10th and the 10th, right? That can be confusing. Okay, so this is a common source of issues. So just to take note of this is obviously UK and this is US. So just to take note of as well, can be a source of confusion. But in any case, what you need to do is now use a built-in pandas function to convert the date column to a date time format. So it's very clear and verbose of exactly what format it needs to be into. And why do you want to convert it? Because pandas has built-in features that allow you to filter based on date as well, a certain date range, or other very useful features, right? So if we keep it as a string, pandas doesn't know its dates, right? Whereas if it knows it's a date, then it can say, okay, well, give me from this month to that month, or give me from this day to that day, or various other features that is built in if you store it as a date time format. So how do we do that? We're going to say, let's access our column called date. And we're going to say, update it. We're going to say pd.to datetime. Datetime and df date. So we're converting the datetime column to datetime, and you're putting it back into the column, right? So let's see what we get. So you run it, and let's do that print info again. And you see that it's a new data type, right? We haven't seen this before, right? We've just seen object, int, and float. So now we see it's a specific date time format. And this allows us to modify and filter based on date quite nicely. So sometimes, again, like if you might have a different date format, I give an example of a few examples there as well. So you can look at it where you can maybe specify the format. So for example, if you have, I think by default, the format is year, month, day. So you can specify it. You can say the format. If we update the parameter, we can say %d stands for day, %m stands for month, and capital Y stands for year. So this is obviously dependent on the data that you have. Okay, so we're specifying, we're expecting the date first, then the month, and then the year. Right, so we can tell pandas this is the format that we're reading in and convert it to the appropriate date format. Okay, so yes, and yeah, that's actually all I wanted to mention there. And what does that allow you to do? Okay, let's have a look at a few examples. So as I said in the notes, you'll see it allows you to filter by data range, calculate maybe the time difference between two times. You can extract a year, month, and day. You can add shifts or lags to data. You can do rolling windows. You can work with time zone or date arithmetic as well. So you have a lot more powerful features to work with if you just keep it as a string, for example. So it's quite useful in that sense. So one of the features I can maybe show you is to store it as I was maybe extract the year and the month and the day. Let me just see what I get. Oh yeah, it doesn't match. So this is the wrong format. But that was just an example I wanted to show you. Let me just comment it out. I got the error here because it doesn't match the format that it's expecting. Yeah, and that should be correct. There we go. Okay, so we have this data frame at the moment. Let's add maybe a few more columns. Let's extract the year, the month, and the day from this date. Right? So how do we do that? So obviously you can think about it, okay, we're working with date, but you can also work with time. I want to work out, extract the hours, minutes, seconds, you can do that. And then you can go to, smaller denominations for time as well. So what examples do we have here? Let's create a new column. Call it year, df date dot dt dot year. Why is it complaining? But that's syntax now. If you run that, then it's dt accessible with date time like values. So why is it not happy? What did I do wrong? What did I do wrong here? Anybody help me? What I did wrong? Why is it complaining? It says the df is it says a data frame has object like that. Oh, we haven't converted it, sorry. Thank you for those that helped me. Which is no one. That's right. Sorry? Why does? So the original file, look at it, time series data. It's first the year, then the month. Oh, let me zoom in. It's first the year, month, and then day. So that's the default format. Then the month, and then the year. And if I do that, it's going to complain. I'm just going to say, no, that's not right. That's not what we see. If I run it, should complain again. Says this doesn't match that. The clearest, thing you'll probably check is the day can't be 2020 days, for example. No, you can, but you first need to, you can change the format, but you first need to read it in the correct date format. And then afterwards you can change it, you can swap it around. So what I'm doing here, what did I mouse? So what I'm doing here, what I'm doing here is I'm reading it in the correct format. Afterwards, I can swap around the day or month, however I want. That's what I'm doing there. In this format, it won't work because it's expecting to see day first, then month and year. But it sees the date, it says, no, that's not the correct format. And it gives the error. So the first thing, read it in your date time format. And then if you want to change it around, then you can move it around however you want. But first read it in a date time format, and then you can modify it. What does Rahul, the question, what does DT do? So DT is just like all the other built-in pandas operations or functions. More accurately, it's an accessor, but let's call it a function that allows you to modify your column, right? So we also saw dot string before, we saw dot extract before, we saw dot as type. So you'll see there are hundreds of these operations or functions that are built into pandas that allows you to modify, extract, or filter that column of data that you're working with. So this is just another example of where we are modifying this dead column. And what we're saying is I'm using the DT accessor or operation, extract the year. All right, that's pretty much all that we're doing. We're extracting the year and we're putting the year inside a new column called df year. That's pretty much it. We run it. Go to Variable Explorer, we'll see that there's a new column that's called year now, right? And you can do the same thing for month and day. I'm not going to go through that. I mean, you can check the notes. It's quite self-explanatory. And again, so you can extract the year, month, to day, and I give examples. Again, why I want to do that. Maybe for time series analysis, seasonal analysis, grouping aggregation, feature engineering for machine learning, database filtering, and just to enhance data integrity. There's no ambiguity. What is the year? Same here with month and day. It's obviously your code gets bigger, but it's completely clear. You don't need to explain the format. You know exactly what column is performing its function. So when you're working with data or date specifically, try to be as clear as possible. Yeah, so the next few sections are just covering some other aspects when you're extracting and transforming data. I think there are a few questions. No, it doesn't seem like it. Yes, you have to start. Well, you can start the project anytime. It's just the due date is, I think, on Monday, I think. So yes, just to reply to your question. Yes, so where was I? Okay, so we're looking at NAND and wrong format. So this is a kind of like a working example where we cover a few things before our lunch break. So yeah, so this is quite a long example, but it covers quite important concepts that you might work with data. So this is a patient data with dates. It has an index column which you want to obviously remove. Is this redundant? We don't need it. The date is in a funny format. And a pulse, max pulse and calories, and you see there's some nans and also missing data. So let's read it in and see what we can do to kind of fix this file. Blessing, yes, you can extract time using the same method. DT stands for date and time. So you can extract time if you want. If you have, you probably can go to like milliseconds as well if you want to, but you can extract time as well. Okay, so can somebody give me the path for patient data dates, please? With quotes, so I don't have to do the quotes myself. In the chat. Oh, you gave me single quotes. Now I have to explain why I'm using single quotes. Yeah, just do the double quotes, then there's no confusion. Felicity, thank you so much. Thank you. You gave me the code itself. Fantastic. Oh, but you gave me single quotes, and I have to explain to people that don't know the difference between single quotes and double quotes. Just use double quotes and you don't have to explain it. Okay, so we have a variable. We have a data frame we created. And let's have a look at it. We have this index column, which we don't want. So can somebody give me the line of code in the chat to get rid of this index column? And let's look at some of the other data. So what do you think happened in this duration column over here? This is some patient data. They're getting the pulse, max pulse and calories from a patient, maybe doing some examination. And then everything seems quite consistent, but they have this value 450. So what do you think about, I mean, do you think it's accurate or not? When you're looking at data for the first time, and this is part of, working out, is your data valid? Right, so thank you. It's most likely an outlier, or maybe there's like a, it was like a finger error, like when they're recording the other times, because if you look at the, it's usually from like 45 to 60 minutes is the usual time for the rest of the duration, right? So hopefully you can see it. Right, it looks like a typo. So we have to kind of find a way to fix that, right? The date, this is in looks like a string, and then here we also have a problem over here. There's an and, so there isn't a date. So now there's a question for you as a researcher. What do I do with this? Is it still valuable to record that or not? Right. So nan just means as nothing was recorded. Or it's an empty value. And then we have consistent. So we have this one, a line of row 26, that the format is not consistent with the rest. And we have a few nans and everything else. Everything else looks okay, right? Okay, so how do we start fixing this data and making it more useful? So somebody gave me the line of code to get rid of the column. Thank you so much. Thank you, Louise. I'm going to use that. So first things first, let's get rid of that redundant column. Oh, Louise, no. Disappointing. You should get an error because your data should be in the same folder that's in mine. And let's just use double quotes, so don't difference. That should work, and my data frame, yeah, we've got that. Okay, so we've done that, right? What's the next thing? I've got the output. Okay, so the one example that I discuss in the note is the date format. So let's first convert the column to a date format. So can I get the code, please, and in the chat? How do I convert the this date column to pandas date format so we can use it a lot better? So please give me the code to change it. How do I convert? Okay, so and you see where, thank you for that. So let's have a look. Why is everybody giving me single quotes? Okay, let's do that. Oh, what happens here? Oh no. But there's a warning. And do you see what did you try that when you sent it to me? Oh yes, Uniswap, you shouldn't be copying it, you should be figuring it out yourself. But this gives an error, so that won't work. So what do I do next? Sorry? Okay, how am I gonna do that? Okay, can you give me the code? No, it is mixed. Oh, I don't think so, Christopher. Isn't that a statement for all programmers? It worked on my one. Well, if it worked on your one, why doesn't it work on my one? Can you find me another way? How are we gonna fix that problem? Okay, let's see. There's another example. Date replace. So you're placing the spaces with a dash, but the dash is still there. So I'm not sure if that made a difference. So let's see if it makes any difference there. Nope, still not happy. Or pandas or Python? Okay, all right. Convert strings to dates. Yeah, or give me the code. I'm stuck here. I have no idea what to do. So I have no idea how to fix this. Spider version. What spider version are you running? Okay. Okay, but mine isn't the same. So I need to find a way to fix this. So what way can I fix? What's probably the easiest way to fix it? I don't know what I'm doing, so just give me advice. What do I do? Manually, what? Yeah, easiest. I can just, well, let me just ignore it. So how do I do that? How do I just ignore that row and just forget about it for now? How do I get rid of that row? Row 26, how to get rid of it? Because all the other examples, it's not helping me. I'm stuck here. No idea what to do. Can't move on without this row. Skip rows. Okay, well, give me the code. I need code to work with. I have no idea what skip rows does, so I need code. I'm gonna try it out. Sorry? Replace laptop. I'm a very poor student. I don't have money to replace a laptop. As type int. Well, Shippo, I need a line of code. I can't copy and paste this. Okay, maybe I am. Let me just copy and see what happens. Nope, I get a syntax error. Update spider version. Okay, let me try update spider version. I'm very new to Panda to everything here, so that also doesn't work. I need a line of code, please. This is gonna help me. Okay, so let's drop the nans. But I don't think drop NA is going to fix. No, it doesn't fix that. I still see that row there. It's giving me problems. Sophia, you can do whatever you want. I just need to get rid of, I need to convert date. I don't know what that does. Chepo. Where are all the experts in Python here? Where are all the experts? How do I just get rid of line 26 makes the most sense for me. So how do I do that? Row 26. I need a line of code, not suggestions or questions. I need a line of code. There's about 70% of you that said that you're a Python expert. So I need a solution to my problem. Skip rows 26. Okay, let's see what this does. Yeah, where's the rest of the data? So definitely not skip rows. Okay, what does this one do? So this one doesn't work, skip rows, because this skips everything until 26. So let's see what this one does. Nope, doesn't do anything. Okay, let's try this one. So Rosina, your one looks identical to Tobekeli from UCT. Let's see about this one. Drop 26. No, my word, it's not, nothing seems to be working. Normally, can you add that poll again, asking the level of Python? You know, the same poll you did yesterday. Okay, let's see as a better. No, it's still there. So can you try it? Can you try first do it on your computer, see if it works, and then send the code, not just guessing. You don't have to use skip rows. You can do whatever you want. So try it on your machine. If it works, then post it, not just guessing. You can put it on the general, can you put it on the general one. Yeah, I don't really want to use. Thank you, Zanele. Drop index in place true. Thank you for that. We did do drop yesterday, so thank you for finally giving a working solution. It took a while for the Python experts here to get that. Okay, so we can move on. We've got 9 minutes left to lunch. So now we can convert this, right? Now we can convert this to date time. Should be able to convert it. And yeah, so now we're in the correct format. We do have another row here, 22, that is not, we don't have it. So obviously it says not a NAND. In that case, it's NAT, so not a time, not a time here, not a time. That's why we have NAT there. So let's just check this. Let's print out the info for this so we can see if it's recorded correctly. tf.info. Okay, well, we can just see it here as well. Duration, yeah. So the date is now correctly stored as a datetime info. So now we can filter it and move it however we want. And just out of interest, I mean, this is one way we can deal with that date that gives us a problem. There are other ways as well, but I mean, it's really up to you if you want to keep the data, modify it, or however you want to work with it. So there are many other options to do that. Yeah, so that is working with the date, so that seems fine. If you want to keep this nan, again, if you want to keep this the nans or the blank values, it's really up to you. It's how you want to interpret the data and use it. You can use the same drop method or drop function to move it if you want. It is explained in the notes. The one last thing we're going to cover in before lunch is what do you do with these nans or these empty values. So again, you can remove it if you want, but another option is to try and replace it or fill it with maybe the average of the column instead. Because you might want to keep there are other columns that do have data in it. So maybe try fill it in with, make it a reasonable assumption what the value might be, so it can still retain the other data. So there's a nice built-in method or function in Python called fill NA. So if we look at the calories column, you can see that there are two nans, right? So one way to approach this again is just to maybe get the average or the mean of the column and just replace it. Replace these nans, this one over here and this one over here, with the average of the entire column. So we still retain the rest of the data, and it hopefully will not skew it too much. So how do we do that? We can create a variable called average calories. Access the data frame, specifically the calories column. Get the average for it. So we did do this yesterday, so should be familiar to you. And what you're going to do is in the calories column itself, we're going to use a built-in method or function to modify this column, just like we did with .str and .extract and .dt, all those things. We're going to say fill NA, which fills a nan or a non-number or a blank value. It's going to fill it with the average calculation we just worked out. And say in place equals true. And why do we do in place equals true? Can anybody let me know in the chat why do in place equals true? While people are thinking about that, you can see now that the average that we worked out for that column, which was 306.56, has now been added to those two nans, right? It's over here and over here. So it just makes the data maybe more complete and hopefully won't skew it too much, right? So again, you can remove the data or fill it. It's really up to you and how you want to work with the data. And I think that is the last thing I wanted to discuss before we just finish this section. Yeah, we'll look at the dropping nans after lunch. So thank you. We'll stop here and then we'll continue at 1:45. We're having a special guest talk by Dr. Kim Martin. She's a PhD in biology and biosciences and biomedical domain, and she'll be speaking about research software engineering. It's a very important, relatively new domain area for researchers, giving you insight into a different career path as a researcher. So please join at 1:45. She'll be giving a talk today, tomorrow, and Thursday on research software engineering. Yeah, you can pose your questions in the chat, but yeah, we will have our lunch now. Thank you very much.